Hello, welcome to Learn Mathematics. In this video I am going to solve a question. This question is from CSIR NET UGC NET June 2011. The question is, using the fact that n equals to 1 to infinity summation over n equals to 1 to infinity minus 1 whole to the power n plus 1 by n equals to log 2, find the value of n equals to summation over n equals to 1 to infinity minus 1 whole to the power n by n into n plus 1. The given options are, first option is 1 minus 2 log 2, second option is 1 plus log 2, third option is log 2 whole square, and fourth option is minus log 2 whole square. Let's try to solve this problem. Solution. What is given? It is given that summation n equals to 1 to infinity minus 1 whole to the power n plus 1 by n equals to log 2. We have to use it to find the value of the given expression. Now what is the given expression? The given expression is n equals to 1 to infinity minus 1 whole to the power n by n into n plus 1. This is our given expression. Now we can rewrite the expression inside the summation. So this is n equals to 1 to infinity and minus 1 whole to the power n into 1 by n into n plus 1. Now note that 1 can be written as n plus 1 minus n equals to 1. So we can replace 1 by n plus 1 minus n. So let me replace that. This is summation n equals to 1 to infinity minus 1 whole to the power n, and 1 can be replaced by n plus 1 minus n divided by n into n plus 1. So this can be written as equals to n equals to 1 to infinity minus 1 whole to the power n. This is 1 by n minus 1 by n plus 1. So now we can use formulas of summation to rewrite this expression, and this expression can be written n equals to 1 to infinity minus 1 whole to the power n 1 by n minus summation of n equals to 1 to infinity minus 1 whole to the power n 1 by n plus 1. Now note that the given sum is minus 1 whole to the power n plus 1 by n, but in the first expression we have minus 1 whole to the power n by 1 by n, and in the second expression we have minus 1 whole to the power n by n plus 1. So we have to change, in this case we have to change this n into, we have to change this n into n plus 1. So how can we change that? To change n into n plus 1, what we have to do, this is summation n equals to 1 to infinity. Now we know that minus 1 whole to the power n can be written as minus 1 into minus 1 into minus 1 whole to the power n, because minus 1 into minus 1 is 1 and 1 into minus 1 whole to the power n is minus 1 whole to the power n. So this can be written as minus 1. Now using the formula of powers, we can write it as minus 1 whole to the power n plus 1. So you can replace minus 1 whole to the power n with minus 1 into minus 1 whole to the power n. So this can be written as minus 1 into minus 1 whole to the power n plus 1 into 1 by n. So now for the second expression, note that minus 1 whole to the now in the second expression you can see that here n is the denominator is n, but in this case the denominator is n plus 1. So you have to change this n plus 1 into n. To change n into n plus 1, we have to replace n, we have to replace this n by n minus 1, and we have to replace this n also by n minus with n minus 1. So now how do we find the limit of this summation? Now in this case, in the first case, what was the first term? The first term for n equals to 1 was minus 1 whole to the power 1 into 1 by 1 plus 1. This is minus half. Now if we consider this case, then what should be the first terms? Minus, this is minus 1 whole to the power n minus 1 by 1 by n minus 1 plus 1 should be minus half. So in that case, minus 1 whole to the power n minus 1 should be negative minus 1, and 1 by n minus 1 plus 1 equals to half. Now we know that 1 by n minus 1, this expression is equals to 1 by n. So we have 1 by n equals to half, so that implies n equals to 2. And if we substitute n equals to 2 in this expression, we can see that minus 1 whole to the power n minus 1 is actually minus 1. So this series, so we can say this series starts from n equals to 2. So we can write that this series is from n equals to 2 to infinity. Now again we can take minus 1 outside of the summation because it doesn't depend on n. So this can be written as minus 1 into n equals to 1 to infinity, minus 1 whole to the power n plus 1 by n, and this can be this is n equals to 2 to infinity minus 1 whole to the power n minus 1, and simplifying this we have 1 by n. Now obviously this is what is the value of this expression? It is given the value of this expression is log 2, so we can write it as minus 1 into log 2 minus. Now in this case, note that minus 1 whole to the power n minus 1 can be written as minus 1 whole to the power n plus 1 by minus 1 whole square, using formula for index. Formula of index, we can write this. So since we know that minus 1 whole square is 1, and anything divided by 1 is so we have this is minus 1 whole to the power n plus 1. So we can write we can replace minus 1 whole to the power n with minus 1 whole to the power n plus 1, and this is 1 by n. Now we can see that the expression inside the summation is same, but here the expression starts from n equals to 1, and in this case expression starts from n equals to 2. So we have to change this summation from n equals to 1. So this is minus 1 into log 2 is minus log 2, and in this case I am writing it n equals to 1 to infinity minus 1 whole to the power n plus 1 into 1 by n. Now what I have done, I have added an extra element into this sum. What is that element? The element is the value of this expression at n equals to value of this expression at n equals to 1. So let me find the value of this expression so that I can subtract it from whole expression. So this is minus 1 whole to the power, substitute n equals to 1 into 1 by 1. So this gives us 1. Since we have added 1 into this expression, we have to subtract it from the expression. So this gives us minus 1. From that I can say this is minus log 2 minus summation of n equals to 1 to infinity minus 1 whole to the power n plus 1 into 1 by n minus 1. I know that value of this expression is log 2. This expression is log 2, so we can write it as a minus log 2 minus log 2 and minus log 2 minus 1. So this is minus log 2, and if we multiply with minus log 2, then we have log 2 and minus 1 into minus 1, minus minus plus 1, so we have 1 minus 2 log 2. So you can see that option 1 is correct.